Hi everyone, welcome to the fifth video of module 6, and here we are going to prepare the dataset and pipeline. First of all, we are going to split the original data frame into X and Y, where X is the independent features, the input columns basically, and Y is your target feature, which is the output column. Then, after splitting the dataset into X and Y, we are going to further split it into the training part and the testing part. We are going to create X train, Y train, and also X test, Y test with the help of one of the features that is available in the scikit-learn library. Now, using the scikit-learn library itself, we are going to use some of its functionality called as pipeline, understand what that pipeline is actually all about, and how you can create one for yourself for this particular problem. And we are going to create this pipeline with one scaler and a classifier. So let's get started with this video. And now what we are going to do is we are going to go ahead and take this particular data frame, a complete data frame, in which we know that except the last column, all of these columns belong to the input data set. And the last column itself is the target or the output data column or the output feature, target feature, whatever you would like to call. So now on this basis, what I'm going to do is I'm going to prepare my input into X and prepare my output into Y. And for that, what I'm going to do over here is I'll simply come over here and say that my X is what? It is all the values in the data frame. So star df, and I'll just use dot ilog, and I'll say that all the rows, comma, everything until the last particular column is going to be my X. So let me just go ahead and check if everything is working fine. So it should have dropped. Okay, there is some kind of a problem. It's because the spelling is wrong. It's completely fine. I'll just run it again. So yes, as we can see that everything is fine. The star type column has been dropped. And that's actually your Y that you want over here. You will say that star df, again use ilog, and say that I want all the rows and the last column itself. And now if I just show you what is Y, it should be giving you some kind of brown bars, whatever it is, right? So yeah, these are the type of output column. Now, the better way of doing this would be to not use .ilog. Rather, I'll be simply using the name of the column. And this is also possible. Whatever suits you the best, you can use it. But now we know that our X and Y is ready. Now we can use this X and Y in order to split it further into the training data set and the testing data set. And for that, what I'm going to do is I'm going to import sklearn.model selection. From this, I'm going to import, or I should say from this, I want to import. What do I want to import? I want to import train test split. And what is it going to do? Let's go ahead and say it. So I want to perform train test split. And what all kind of inputs does it take? Let's try to see that. I just press comma over here, and it's not tet, it's actually TEST test. And now let's just wait what type of inputs it's going to take in. And here is the documentation, and we can quickly see that the parameters that we are going to pass in the first things will be the input arrays, that is X comma Y. Then what is the test size? And okay, these are the ones that I'll be using. That is, what is my X, that is the input data. Then what is my output data, that is the output column. On top of this, I'll also pass in my test size. And I'll be saying that the 20% of my 240 stars are going to become my test data set. And on top of that, I'm also going to fix the randomization. So I'll do that with the help of random state. This is the random state input I'll be passing over here, and just give some number as 42. And now I can go ahead and say that the output of this will be X train, X test, and Y train, and Y test. And now if I run this and check if everything is done successfully or not, I can create one more code cell and check if this is fine or not. So this is my X train. So this is the X train that we are having. You can clearly see that the randomization has indeed happened. Now it's not in the format of 0, 1, 2, 3, 4, 5. Any type of rows has been taken from the original data set. And this is the output that we have created for the X train. Now let's look into the X test. Now this X test is just the 20% of the data, and over here you cannot find the same type of rows as we had for the X train. And now we can go ahead and look into Y train and Y test. Y train will be the respective outputs that we had for the X train. For example, if you're having 139 over here, then 60 over here, then the same indexes we must have in the X train as well. Let's go ahead and cross check that as well. So it is X train, TRAIN, right? I'll run this code. It should be 139 and 60. If it's not, then there is some kind of a problem. So it is indeed 139 and 60. So everything is making sense. So this was a quick review with respect to what we have done. And now the next step is to create a pipeline. Now, what is this pipeline? Well, to understand all of these things in a proper way, such that you can really understand what is the pipeline and why do we use it, you need to know that we don't really go ahead and directly implement training on this X train, and we don't really go ahead and implement the prediction on this X test. There are some bunch of steps which we call as data pre-processing steps that we apply to prepare this data before we start doing this kind of training process or before we make any kind of predictions on this testing data. So this pipeline is a way through which you can organize all of the steps in a way that eliminates all these kind of things that you will have to do without the pipeline. So to make you understand this in a proper way, let me just give you this example. Okay. So one of the steps that we are going to perform on this training data is the scaling part. Now, why do we require a scaling? What is the scaling? Let's understand that first of all. So I'm having this X train data. Now I just want you focus on one of the column. Let's say for example, luminosity. Now in this luminosity, you can clearly see that some of the values are very small. Rather, some of the different values in the same column is having a very huge number. There is a huge difference between them. Now with the help of this kind of scaling process that I am going to implement over here, it's going to prepare this kind of particular column in a way through which your models will be able to make a lot of sense and also train in a much more quicker way. That's the reason why we use this kind of scaling process as one of the part during the pre-processing on the given data. Now, what type of scaling technique are we going to use over here? I'm going to use standard scaler. Now, what is the job of the standard scaler? It's going to first of all calculate mean of that given input column. Okay. Along with that, it's also going to calculate standard deviation. Now, after this thing is calculated, the transformation happens. That's where the scaling happens, where it takes all of these inputs, all of it inputs. Let's just call it as X. It subtracts all of these inputs from the mean of the data. All right. And then it divides this numerator. Okay. All of these things that you are having in the top is in the numerator. Okay. It's not like X minus X mean over X standard deviation. All of these things are there in the numerator. And then in the denominator, you are having X standard deviation. Now, you need to understand over here that the mean that has been calculated is for one column over here, and all of this transformation will happen with respect to that particular column. Now, what I am going to do is I'm going to implement this kind of scaling technique for each and every column that we are having over here in a hope that your models will be able to understand this data in a much more proper way and eventually help it during the training process. Now, just imagine this thing. I have used this kind of mean of the data that we are having and also the standard deviation, then transformed it accordingly. Now, what's really going to happen if I don't perform the same type of scaling technique on my X test data and just ask your model to predict automatically without doing this kind of scaling? Your models will be confused. It's going to give you some incorrect predictions. Okay. The reason behind that is, again, I'll just give you this kind of example so that you are able to understand it in a proper way. Let's say, just for example, in your X train data, there are a lot of A's. Okay, there are a lot of A's. Now, to explain what this A is, you are doing some of the transformation over here. You want your model to understand that what is A in the proper way. You are just going to assign some of a number to it. Let's say, for example, 1. So this is the transformation that you have done, that wherever there was A, you converted that into 1, you transformed it into 1, and now your model is going to get this 1 number. And your models will automatically create this kind of a sense of, like, with the help of this weights and bias, that how much amount of weightage this has in the prediction part. So this is only possible because we have given 1 as an input to the model. It's not A anymore. We have done some of the transformation. We said that A is equal to 1, and this 1 has gone to the model. Now, during the testing part, if I am not going to perform this kind of scaling technique without doing any kind of transformation, let's say if I'm going to give A directly to the model and say that now what is the prediction. Your model will be confused. If it has not seen A in the training process, it's just not going to have any kind of sense of what this A is. And it's going to behave in a way that you would not like it to behave. And therefore, for your model to know that this A that you are having is actually 1, you need to again apply the same step, that is the scaling step over here in this example, so that it's going to give you the value of A is equal to 1. So what we have done over here is that we have implemented one of the step in the data pre-processing, that is called scaling, for the training data as well as for the testing data. And now you can go ahead and do some of the training for this data, and for the predictions you can use this test data because it is already transformed into a way that your model is going to understand. Now if I have to do this without the pipeline, there are few steps that I'll have to keep on repeating for the X-train part and for the X-test part. But while repeating the steps, there is again one common pitfall that most of beginners will face. And that is, while repeating this thing as it is, if I copy this thing and paste it again over here, that is in a hope that I am going to implement the same type of standard scaling technique to convert all of these X's into a way these X's were converted for the training part. So now what you have done is you have calculated a new value of mean and the standard deviation from the X test, and then you are implementing it on the input data that you are having for the testing part. And now just because you are hoping that both of this will give you the same transformation, for example, let's say if your X is going to be 1 in the actual data set for the training and the testing, the training part is going to convert this into, let's say for example, 3.4. Just an example. Now if you hope that the same type of transformation happens in your X test data, that in the X test data if there is 1, it should be converted to 3.4 as well. This is not going to happen. The reason behind that is there will be a new value of mean and the standard deviation for the X test data. So how can we expect the same type of output for the same value of X that we are trying to transform? It's not going to happen. So this is the common pitfall that almost all the beginners face. And to just streamline this whole process, we use pipeline. Well, to be honest, there is a lot of different things you can do with this kind of pipeline on top of what I've just explained. And all of these things will only start making sense once you start implementing it. So without any further ado, let me just go ahead and start implementing the pipeline. So for now, because our data is not that much complex, we can simply use only one data pre-processing step over here, that is the scaling thing. And I'll be using the standard scaler. And for this, I'll be requiring some of the libraries. I'll just copy this thing and paste it over here. All right. From the sklearn.preprocessing, I am calling the standard scaler. And it's because of this, I'll be able to transform whatever is my current data in the Xtrain and Xtest into something else that your models will be able to digest in a proper way and speed up the training process. And then because I'm trying to implement the logistic regression, I'm also going to import it from the sklearn.linear model. And lastly, I'm also having my pipeline that is imported from the sklearn.pipeline. Now, how does this work? So the first thing I would do is to create the pipeline with standard scalar and logistic regression model. So these are the two steps I'll be having in my pipeline. And to create the pipeline, I'll just need to create its object over here. I can do it by calling this pipeline. I'll also name it as this is my pipeline equals to pipeline. And the way that we can pass in the input is with the help of the parenthesis. And it takes list of steps as an input, and all of the steps will be in the format of a tuple. So what I'm trying to say is that I'm going to create this kind of a way through which I can pass in the inputs in the format of list of some different steps. And the first thing that I'll be passing in will be a tuple, and this tuple will represent one step. So the first step that I'm going to implement is the scalar, and I'm also going to create an object for the scalar over here by simply copying this part. Okay, let me just go ahead, copy this and paste it over here. So it created an object for a scaling part. Now after this, the next step if I have to add, I'll put a comma, create a tuple and call it as, let's say for example, classifier. Okay, because I'm trying to do this kind of classification, I'll just call it as a classifier. And then you can also call it as a logistic regression, whatever you like. It's completely your choice. There is no worry with respect to that. You can have your own name for the object that you're trying to create over here. So now over here, I'll be calling this logistic regression. Okay, I'm actually trying to create the object for this logistic regression that I can use for the training part. as well as for the predictions part. So everything is done. So I'll also add a comment over here. So this is my step 1 and this is my step 2. I just have one extra space. This is my step 2 and this is my final pipeline that I have created over here. Now I can use the same pipeline for the training part as well as for the prediction part. Alright guys, now it's time to wrap up this video over here, and you have learned about how you can split your X and Y into training data and the testing data, then understood about what is this pipeline inside this sklearn library, and created a pipeline for yourself using a standard scaler and a logistic regression classifier. Now in the next video, we are going to use this pipeline that we have created over here, train that pipeline, and then use that train pipeline to test it basically on the test data that we have prepared over here.